If you've ever flown in an airplane, you are probably familiar with turbulence. Even for the most experienced flyers, the sudden, sometimes violent, irregular air motion can be an unsettling experience. In most cases, turbulence is merely an inconvenience that passengers and flight crews must endure. But in cases of severe turbulence, the violent shaking can not only cause serious injury to passengers and crew, it can also be fatal. In an effort to help aircraft avoid turbulence, researchers at NASA are testing new onboard aircraft systems. The Airborne Research Integrated Experiment System, or ARES, uses experimental systems that detect turbulence minutes before an aircraft encounters it. This new system may allow pilots to avoid severe turbulence, making flying safer. I spoke with Neil O'Connor in the Crew Systems Branch at NASA Langley Research Center to find out more.
You can think of turbulence as any phenomenon in the atmosphere that's going to upset the airplane. Changes in wind that can cause the airplane to be disrupted from its normal flight. You can also get turbulence whenever you have wind rushing over the top of a mountain. The leeward side of a mountain can be very turbulent. You can also get turbulence wherever the jet stream is active, because there's a high wind speed in the region of the jet stream, but slower right nearby. Thunderstorms can cause turbulence. Everyone knows right nearby the storm, but sometimes even 50 or 100 miles away in the clear air, you can get turbulence from a thunderstorm.
So Neil, how are pilots avoiding severe turbulence now?
For the most part, pilots have several simple options. They listen to the radio to hear if other pilots have already encountered turbulence in that area. So that means somebody's already been hit. They can also look at their onboard radar and try to, based on their experience, can extrapolate what they think might be, but it's not really foolproof. And they can also get a general forecast from the government sources or from their own airline.
Here we got some turbulence now. We're about 3 miles short.
Though seldom damaging to modern aircraft, turbulence is the leading cause of in-flight injuries among passengers and flight crews. On average, 58 injuries aboard aircraft are reported each year. 98% of these injuries occur when unsuspecting passengers or crew are unbuckled or out of their seats when an aircraft encounters turbulence. Currently, there are no instruments on board aircraft to detect turbulence before a plane encounters it. NASA researchers hope to change this by incorporating new turbulence radar systems within existing onboard weather radars. With this new radar system in place, researchers hope to provide pilots with enough warning to either avoid the turbulent area or at least give passengers and flight attendants enough time to return to their seats and buckle up.
The radar system itself will just be a software upgrade to the existing wind shear radar that's already on board the airplanes. The beauty of that, of course, is that since it's just an upgrade to an already certified piece of hardware, it should be relatively inexpensive because you're just incrementally changing what's out there already.
So Neil, tell me how exactly this new system's going to work.
The way it'll work for the pilot is that he'll flip a switch that's labeled turbulence, and then he'll have the new software running. It'll be running mostly at cruise altitudes where pilots typically allow people to move around the cabin. It's not a problem when you're climbing or descending because everyone's already strapped in. So if you have a turbulence encounter there, it's not a big issue because everyone's already buckled in. But we want to help make a difference at altitude when you don't always know there's going to be turbulence out there. And this new product will be able to increase the capability of the system and increase the pilot's confidence in the accuracy of the system, leading to a better, safer environment.
Besides radar, is there any other kind of research with turbulence?
Doing other research, both onboard and otherwise. The onboard system is called the in situ turbulence warning system, and that's a system that uses accelerometers on the airplane to measure what the airplane feels at a given moment. That'll be transmitted automatically to all other airplanes in the general area, along with the location. And the receiving airplane will take that data and adapt it to its own size and class of airplane, and then assess whether or not it's a threat to that airplane. And if it's a threat, then it'll tell the pilot. Another way of enhancing what we have now is improving our forecast capability. And that gets into modeling of the weather and other phenomena of the atmosphere to better understand what the potential is for turbulence.
So Neil, what are your hopes for this project?
Well, the ultimate goal, of course, is to increase the safety and reduce injuries caused by turbulence on the airplane. Right now, it's very easy to prevent injuries when you know you're going to have turbulence. The pilot says, hey, we got to buckle up for a few minutes. Everyone does it, no one gets hurt. But you don't always know the turbulence is coming. So sometimes if you don't know, people are walking around and the plane gets a lurch, someone's going to get hurt. And that happens now. So we know we can make a difference by improving the product.